So basically, this video is split into 3 parts. But you have to split into 3 parts. The minimum. It has to be done properly. Properly. Too well properly. It has to be done correctly with consensus. So let me start with the quantum theory. I have my quantum field theory expansion. But I got my notes, everything here, so it should be fine in order actually. So basically, isn't policy in my constitution work is optional, and we have to optimize all way of work. So there's something called a consensus system. Consensus means like you give consent. You give consent. You don't wait for someone to ask for consent. You give consent. So that's the idea of consensus. So it's basically like a sparse modeling of attack, defense, and offense. Because if someone that's autistic like me wants to be attacked, don't want to be attacked, they don't have to give consent for that. So that's just bare minimum human rights. I don't attack a human being. Oh, do you want consent to admit attack you? And attack if I'm attacking them, offending them if I'm offending them. Obviously, if I want to defend myself, I attack them indirectly. So I defend myself and attack someone that's autistic or neurodivergent, etc. So I defend myself to give them to give them my best. Like thorough counsel did to me, and I can defend myself directly by like my social worker going to me and saying nonsense to me. So basically, that's just a sparse model. So consensus means like you don't wait till you to give consent to someone. You act, it's your right for someone to do it. So it's basically based on 2-to-1 mapping. So basically, you have 2 public keys on 1 private key. You keep I keep the private key, but I never tell people the public key. People can put the public key on the internet, don't really care. But the 2 public keys work on the same data, the same sparse data, sparse defense data. But they rotate themselves because they know how to rotate. Because if they're the public keys, they only keep the data together. But if you can expose this on internet, just post it on x.com, and they'll be exposed to the internet forever. But that's what I'm saying, guys. The sparse method is literally just having the keys in there, there forever, and they'll be there forever, because they will they last forever. But if I have 2 private keys, I can put 1 information, and if the information changes, I know it's been tampered with. So if you want to catch someone, just put something in like that in something there, and see what they're doing. Okay, back to my business. Basically, this is my quantum theory model. Oh, I've got it rolling around. I've never got it back to the front, guys. This video I have to upload it as soon as possible. Okay, so today's video is on something called my model of quantum field theory. Okay, so basically it's not why is anything coherent. So basically I'm gonna start quickly. So you got the coherence operators, which I made. A union A is A plus A equals 2A, or and because it's union, so it's union, set union, and number theory union. A plus A times A equals A squared. So this is this is just a model of it. So the operands are plus and times. To define the union of a potentiation, as a coherent system, a coherent quantum system. Define it as a coherent quantum system. Things that don't collapse under the sheer noise of the world. But I then A star. Excuse me, my A star. Because I'm giving myself an A star in the quantum physics because I know I solved the problem. I think for myself anyway. All substrates are structured. So basically, the substrates things are basically you can make it a substrate. If you get all the information you ever need to solve that quantum problem. But that substrate basically that's Cartesian model. So if you can give it if you give like a system like a quantum computer, the structure to observe radio waves. You can see radio waves, but you don't need to see the whole electromagnetic spectrum. Which we're going with this right, by the way. So and the structure is like the flexible one. So if the substrate is just the substructure, it's a substrate, it's a substructure, so it's a substrate, it's a part of that bigger set. The radio wave is part of the biggest of the radio waves of the whole electromagnetic spectrum. Okay, comprende, guys? Okay, now for every union, there's a non-union, a disjoint. Basically, just set theory. Union, negate, there's a disjoint, on subset of, that's just set theory with number theory, classical number theory and the polar number theory. Because I'm trying to give you the most comprehensive example, precise and accurate measurement of the system. A disjoint A minus A equals epsilon A. Now epsilon, so basically the epsilon state is this. So you see this epsilon state, number? You see this, guys? You have to remember. See that picture? See This is very important to understand. The epsilon state is just a nil state. It just means nothing. But the nil state has two ways. The nil means nothing, but what does nothing mean? Nothing means nothing. The quantum field. So the field around it, also nothing means. So the epsilon field for A is nothing. So A can be radio waves. Rent money equals rent money. Wait, so rent money is okay. Rent when you pay rent, rent money, rent. When I rent, I'm not paying you because I'm using an example. Rent for radio waves, M for microwaves. Rent money for microwaves, microwave ovens, microwave wave signal. I for infrared, indigo for infrared. I for infrared is visible spectrum. The light we see, visible. You can see the waves. The color, everything. Light money is visible. Under ultraviolet, X for X-ray, X. Ultraviolet cancer detection, X-ray, gamma rays. For X-ray my bones. Ultraviolet like sun rays. Sun rays are ultraviolet. Things when you see in the sun, you get ultraviolet rays. You can get burnt by the sun. You can get especially when they put cream on, because they affect the cream. If you tan too much, you tan in the sun, you get used ultraviolet. Especially when you get used to tan, ultraviolet, extraviolet, the X-ray bones for the bones. Bones that can see your calcium. Gamma rays, gamma rays or radiation. This can cohere the whole biological system. They get from the Earth's shielding you from the wave. I'll come back to Earth shielding you from the wave, but the epsilon encoding state has to be defined properly before you even start this. So I'm gonna give you that the model here. So for the disjoint set A not A minus A is epsilon A, but epsilon A is just radio waves, not even like the full spectrum. Radio waves. What do I mean by radio waves? You can basically, it's not visible light now. I'm just talking about radio waves. This because we want to start thinking about other things in our lives, moving our lives correct. Radio waves. So radio wave is like interacts with other radio waves. So basically, I tune my channel, but it's not a perfect tune because it gets static in it. Because the student channels I'm disconnected from I'm trying to tune out, but the channel tune is not perfect because it's trying to tune in and out of the whole entire wave spectrum. Another problem with the radio system, it doesn't think about the radio realm, radio waves alone. It has to focus. You can't tune in out. Basically, it's working. Basically, the digital system does not decode it coherently via the quantum principles. Basically, digital computers can do it, but we don't really think about that. We want to live our lives. So I'm making my own radio to do this because I'm really bored of this. So my goal is to make my own radio. No, so I can hear radios forever in cars. No matter where I go, I get a radio signal. Okay, so red shift. We are moving away. The universe is expanding. Simple stuff. Red shift. We get more red waves. So why this matters? So A minus A is epsilon A. So this is 0. If I 2 minus 2 is 0. 0 because it's nothing. But that nothing is something. Nothing is something. So, but the system has to encode it still as nothing. So we get two basically you get EE, you get epsilon state, which is nothing A. And you get epsilon of A. So epsilon A. And basically there's no state and there's no transition. That's a nil, NIL. Now do you remember that? So basically the nil of radio wave system, basically before we start tuning a radio wave, you have to tune it to an angle. Coherent, you have to tune it to something. But the system has to rotate it basically. So if I'm not tuning it to something, I'm tuning it to nothing. I'm tuning to basically the other spectrum, because there's nothing to tune it, so you have to go round. So the disjoint A is nil of various sets, and that's the big one at the mass. So basically, there's a clamp function. Okay, but B is what human sees. I am measuring A. So basically, it's a measurement problem. So I want to measure B. B is a radio channel. But I'm from A. But my basically quantum principles, superposition, I don't really have to go to A or to B to tune it, because it's just there. I'm just to find B, and I'm there. I'm there. I'm already there in the metaphysical, in the radios, because if I can find where it is, I already know where I'm going, what I'm listening to, because there's no information to decode. It's just the whole structure has been given to me. But I'm basically like a photon. I'm looking this way. But I'm looking this way, but the photon's coming in my eyes this way. The light's coming on when my light goes into this way, I see you guys, you in the future. So I'm seeing myself here, but the photon is just going this way. So what I'm saying to you, there's kind of a polarization heuristic there. So the thing about I define it as a polarization, a polarity. But polarities work on heuristics, but these heuristics are equity bound. They're like a computational equity. I don't like the term computational equity. I like the term because it means I can be free. I need some equilibrium, computational equilibrium. Because the system basically I'm seeing the computer right now, but the computer can't see me. Can't see me because there's nothing observing my state. Because the computer you can see me, yes, my camera can see me, but there's nothing measuring my state. To make me basically I can basically this is what the probability is. So basically, you can give example. If I tune into a radio, I'm tuning in and out of of channels, but these channels are often a log wave. But every channel has a message you want to broadcast me, and the message can be the actual information I'm getting from the system. So what I'm saying to you guys, it's a cause and effect duality. Why, for this system to work for the whole radio channel, there has to be some kind of a uniformity amongst all radio channels. Because if everyone shares one channel, then it starts to get noisy, and no one can hear each other. No one can find anyone or hear anything. The information of B. So A, I'm trying to go from A to B. Is imposed by glimpse. Basically, I can glimpse that B and try to get information out of it. But it's not perfect, so my system just then I lose access to A. So that's what I'm saying. Again, basically, I'm looking at B. I'm trying. Oh, why can't I find B? I guess the stress is like I think it's more of stress because it's from like just like a joke. Because I guess quantum systems have to be really properly. Basically, do it properly. So I'm thinking about the stress of my life as an analogy to the strain of the system. Trying to measure something it doesn't know, or doesn't know how to store. Because I wake up, I hear the radio, but I don't know what the radio channels are. LBC station, NBC News, NBC, all these channels, I don't know where they are. I just tune them. I can find them sometime in the analog world. But the digital form, cause I can find, you can switch channels as well. You can jump. But the idea of that to get something out of this channel. So I can also find that channel wherever it moves. So basically, the information is not really my concern. It's where I'm operating, the field of information I'm operating, the substructure is where I'm looking for. I'm looking for basically you can model this as a Morse code, Namdi. Morse code, basically you can use Morse code to predict ahead of time. Using directed symbiotic evolution with C0 gates and XOR gates. Basically, C0 gates are for modeling a system that can go on and forever. So basically, X my A not. So basically, you can get a glimpse at a system, but you don't get any information that you want out of it. You can keep learning from that information indefinitely, but that system giving you nothing, next to nothing, because he doesn't want you to hear my eyes seeing like you at a position. Basically, I can see you on your phone because the system is enough. But I want to see you in real time. It doesn't matter where you are. I want to see you from your eyes to your eyes. But I don't want to know where you are. But we live in the same place. It's basically the address is we live in the same place. But I want to know you. So basically, time is an element of this. Because it's cause and effect duality. I'm trying to get my childhood memories back. Going to Navy and fixing my childhood. I just think about stress. May or may not. The one basically. Okay. So the problem is A is a substructure of B. But B can be a radio wave too, or not. Can be a poisoned, or corrupt. So basically, it can be a noise or a signal. Can be an incomplete signal. But doesn't get it. I'm not getting the full picture of where the location channel be. What hertz it is, like 1,000 hertz, 180 hertz, 1,000 hertz, 100 hertz is standard for your radio signals. But I think that's able to see later. But didn't they change it to 280 hertz? Just for reality check. Please someone find LBC News and where they are now. Airplane. Basically, you have to find some kind of tri-directional consensus encoding system. So I can pull information from A to B without knowing what B is. But if B, basically, I'm thinking of it like further alias systems. So basically, if I have like a B doesn't need to give me all the consensus to know where it is. To not know. Basically, we can give me three type of consensus, based on a superposition. The first consensus labeled with a B, LBC can give me is what? We're never in this, we never allow this to go in this formation. Before you even try to find me, wherever you are in region, you never allow to look this place because I will never be there. Because it doesn't make sense looking there. So there's like a range of 100 to 100 hertz to 180 hertz. It's like in my boundary. So I will never jump to, because region system do it 100 hertz to 180 hertz. I just think, but that's more because it's superposition. If I want to position myself, polarity, I have to define some kind of clamp function that never exceeds its boundary. Because that's what they're buying. So polarity, because I want to superposition. Basically, if you want to connect with me, you want to never be out of bound between 100 and 180. Very important, you guys understand that hertz, which is the frequency of hertz for radio is, and then position entanglement. For you to connect with me, you have to call in on this phone number, so you can speak on your own. So that's where you can relay. So you can, this phone number, it's like a metadata, but the metadata is just the phone number. So interference, constructive from it, disconstructive from it. Basically, they have to work on a quantum physics radio. For you to speak to me on my phone, LBC, I have to call in on this quantum phone number. Basically it's like I'm in this, and this is like a bound to the 189 to range, because that allows them to jump. Basically, if they go from 180 to 162, 186, 180, 100 to 100, so 100 hertz to 180, 180. 100 to 180, I do 175. There's some kind of coding function. Let's call it Morse code. Basically, I don't prefer anything in word, because I prefer in functors. Basically, the Morse code has some pattern to it, but that pattern is not easily, it doesn't give you information. Full information is makes it more flexible for everyone. So you can define become a 2-to-1 topology. So they keep two public keys because they protect their channels. They don't give us, basically give us two public private keys. So we don't know where the channel is, but they keep one public key, and they give us the full consensus to find us for the public key. And how this will work, guys? Very well, guys. You do this right. So I'm gonna try to compute it now. Let's try to compute it. Because I love computers. Basically, you get 180 hertz, 100 hertz again to 180 hertz. So you get it. So you get like a basically this. You get a 2-to-1. They give us two. They keep what, two public keys. So here, so basically, they shuffle algorithm. They shuffle twice and give us one output. So basically, if it's a random shuffle, they give us 100 to 188, and then a shuffle, and then our B in this zone. I must basically pick a random. Basically, can start with randomness and become something else. Basically it's a random generator, but it's get towards evolution. So that's what I'm saying. You don't get, it's not magic trick. It's like a magic trick in real life. Basically, it's not a magic trick in this computer. So basically, I have two random numbers, two private. You have two public keys you keep, and they have one private key. So this can be two Morse code or two numbers. Two number A. Okay. What's A100 between 180 to give two numbers. 24 plus 6. Oh yes, I remember. I'm trying to compute it now. Okay, so the two numbers are gonna give you is based on the mapping. So if I did a disjoint, things I don't want to do. So let me just do a disjoint first. So disjoint first is the 100 and 100 180 hertz, and that would be the maximum disjoint from this would be union 100 disjoint 180 plus 180 plus 100 equals what? The hertz. This I'm not allowed to go past. 180 plus 100 is what? 280. Now 280 is what? 280. Oh, sorry. Let me a joint. Okay, 180 minus. Okay, basically 100 to 180 is just rounded. 180 minus 80 minus 80 hertz. I will never have to go to 80 minus 80 hertz. But this is a shuffle I'm talking about. So order never matters. But you have to do the invert. Basically, fucking fly. What the difference? So basically, 100 minus 180 hertz is a valid answer 1, which is the first answer. So I have to get two numbers 1, two numbers 2. This is the first key. 180 key 1 minus 80 hertz. And now I flip it. Now 100. Now 180 what minus 100 is what 80. So I'll never be in what channel? 80 minus 82 minus 80 hertz to minus 80 hertz to 100. No, minus 80 hertz and so because 100 minus 82 and 80 to minus 80 to 80 hertz. I'll never be in that range, so don't even search me there. But now I have to get somewhere I will be. So I'll be here 100. It's basically 100 plus 80. 100 plus 180 is what? So let me use my calculator, guys. It's annoying me. So this doesn't keep a encoding table for this now. Let me try to do it properly. Guys, I should basically do this properly, you know, guys. If I fail this, I'll have to chuck this table and start again. Okay, basically it's not stopping now, but the video is trying to get over. So just to get 100 to 100, 180, give me 186. And I do a minus, a disjoint, a minus on 100 plus 100 minus 180. It's minus 80, and then 2. 180 minus minus 100. That'll be what? 100. 180 minus basically get my basically you get my 180 minus plus 100 minus 100 because you know basically plus 100 because you know plus 100 because you know you don't flip it, you keep the plus, you know. 180 minus 180 plus 100, that would be what? Minus 126. This will be I'll be not in oh no, sorry, I'll be basically minus 180 minus 80 minus 180 plus 100. Okay, let me do it properly. So I'll do it properly. Minus 100 plus minus 180. 280 hertz. So I'll never be in the 280 hertz range. Oh, sorry. 100 minus 180. We'll calculate. 8. I'll never be in 80, and I'll flip it the other way because they're reciprocal. I have to think about where I'll be. That will be minus 180 minus 100. This is 0, 80. That'll be 80. So I'll never be in the 80 hertz range. 80 hertz because you know I get 280 hertz. I'll never be in 80 hertz because you know I get 80 hertz. 280 hertz. I'll never be there. I'll never be. You don't start looking over them, you know. But that's just the state of not being. But that's a G center. That's just 2 minus 2. But this is just the first. This is the start. You see this 280 hertz. That just means the start. Now I get to where I'll be. So basically, just get two numbers. Oh no! Stop! Oh, stop. Okay, basically, again, that's the start of the range. And now do 100 plus 180 is what? 108 plus 180. Basically, the start of the end is negative. So this is just a positive end. This is the positive. This is the end of the start. This is the start of the end. So you get start end. So you get the end of the start. When you start looking for me, and you get the start of the start of the range. So if I get the start and that'll be, oh, this is start end. That'll be the division. So I can do 100 divided by because you know you have to think about all the things that 100 divided by 80. 100 divided by 180 is what? It's 0.5. 0.5, and that's the start of the start. And then you get 180 divided by 100, and that'll be what? 1.8. So that'll be 0.5 to 1.8. I will never be there. Never be there. Will never be there. Never be in 0.5 to 1. That's another channel or something else going on there. I don't know. So there's something going on there, and then you get the other one of the start. So 0.5 hertz to 1.8 hertz albeit, and you get the 80 to 80 hertz, because you flip it 100 minus 180 is 80, and you get 80 hertz, so to 80, and that'll be stop. 0.5 to 80. Don't look for me there. Min to max. For LBC. Now it can be 186 anything, but when you want to change, you have to change the whole thing. Because you can buy new things. But let's keep it simple for now. Now let's continue. So where would I be? Where would I be? So I have to calculate the union set. So all the things that union equals b squared, a squared, a squared. I'm looking for what? Obviously I'm gonna have like a key here. Obviously, basically that's the first key. Okay, that's just the standard key. This is the seed, the real world seed. Sorry, this is like a seed. So if you don't want to see me, you start from here, 0.5 to 0. I will never be here. But this is just for 0.5 to 0.8. We can find the 0.5 to 80. 0.5 to 80. Don't look for me here. I'll never be there. But I'll never be there. So that's the first one, 280. 80 hertz. And that'll be the normal standard fee. But that's not the full thing, basically. So what I'll do now is a union, the and. I'll never be there. But there's something called the thing. Basically, if I'll never be there, there has to be a negative equivalent of it. So, so if you flip all the operators, that's a conjugate. So you have to basically, if I'm never here in the positive one, 0.5 to 8 is a negative one, the one that's the worst case for me to be. So that's the positive one. So I have to do it again. So I do the same thing, minus 100, basically 100. So basically it's go 100 hertz to 180 hertz. But now the opposite will be 100. You conjugate. It's called a conjugate. The flip, and it's called conjugate 100 hertz to minus 100 hertz. So basically, if I do that. So you get minus 100 to 100 hertz. So it's minus 100. So how much 100 plus 100 plus minus 180 will make it minus 180. Minus 180 plus 1. So we get this 100 plus 180 minus 1, basically 100 plus what? So basically that's the opposite one. So I'm trying to unify it. So basically the opposite one will be the unification of it. But this not basically you got the union one, you got the first one. I'll be in here, the QA one. So I'm gonna be here, but you get the flipped other one. So I'll be in union, this union type A, this is classic one, but the conjugate one will be type B. You flip on it. So this will be the disunion. So that'll be minus 100 hertz to with the range of minus 180, because it's minus 1, and that'll be the disunion. So this usually will be like minus 180, 100 hertz plus. You're gonna no. Basically, you calculate the minus because you don't calculate the addition. No, stop. Let me just start again. So you get minus 100 minus what? Minus 100 minus what? Because you keep the negative sign. Because you minus what? Minus 180. Plus 180. So that'll be minus plus minus is minus. So minus 80. 0. Oh, that'll be 8. 0 8 1 plus minus plus plus minus plus is minus plus is minus plus means minus is minus. So minus minus that'll be plus 180. So you never see me in the range plus 180, 0.5 to 80, and then A1 disunion 1, you disunion A, and then you disunion B. You can disunion B. That would be the conjugate. That would be, you never see me in the range of plus 180 and above to the other one, the conjugate of the thing. So basically, the space is kind of a circle. You can use the pi to the number pi to compute this. Because you can compute the area we can see in the field of view, or you can compute mathematically. There's this is more theoretical now, but I'm gonna just get it done. So that's minus 100. You said, but you get disjoint of 1. Disjoint 1, disjoint A, 0.5 to what? To 80 hertz, and then disjoint B. Disjoint B will be 180 hertz to that's a plus 180 to what 0.5, because that's basically this is check and win. So basically this isn't like basically just the opposite of it, but that's just the disjoint A and B of the radio wave one, and then we got the joint that's union one, union B, union B, because I'm A, union B, union B. So union B will be the same thing, but where I want to be. So union B will be what? 100 again, 100 to 180 again, and then union B will be union B from A. We'll find where union B will be where A to B. So I pick a random number. Where do I want to be? 100 to 180. And then I say, okay, where do you want me? I'll be in this range, but give me some kind of random. So this is like B. This is like the subcategory. So B can be some kind of two numbers given to you based on entanglement. How to entangle yourself to this signal and here and stop the order and discard of order noise. It can just be basically the metadata has been given already. This is the A. Like to me A. But there's two keys. Public key 1. For me, just listening. B, probably B, me trying to use. I get my own personal one. It can be like a GUID, something that's referral to me. So to B, I can build like the same. Basically, I can put like two numbers too. I can put like let me just pick two numbers. 25, because that's a big range. And 10, because there's two keys to heal each other. Based on sparse models here. But I'm just trying to prove auras here. Okay, the A for alpha, U for umbrella, R for Romeo, A for alpha. CL, CLC, but not CLC. So basically, I can now define. How do I define it? The way basically this is something I want to be. Something I want to know. So this I can't be here. I never want to be here. Something I want to know. So I can see this somewhere else. Based on the seed evolution thing, and keep the private key. My reference to it. But I'm saying that's how it works in the real world. Here, let me try to do it. So basically, you can start basically. Since I never want to be someone, I have to give someone. Let me just give myself 25 and 10. 100 plus 25 hertz. 25 hertz is what? 125. So my seed is what? My personal seed is 25. A, and then he has to work with some operation. 25 union. Union 25. Let's give you uniform. 25 hertz. I need 50 hertz range maximum. So that'll be 150 hertz for my key to log in 150 hertz from 100 from 0. So basically 0 to 0.5 to 180 hertz. I'm allowed from here, if I start at 0.5 hertz, I'm allowed to be plus 50 hertz in case anybody's noticing on that channel rate, that channel of analog channel. So I can get 50 hertz ahead. To get two keys, 25 and 25 hertz extra. So I get 50 keys total, because it's not a digital channel, it's an analog channel. So I can glitch that channel, I can be on that channel, but I cannot be if I want to stop. If I want to close my channel, I'll just close one of both my keys to rejoin. And then we go shuffling. So I can move this 0.5 here, plus 50. If I'm dynamic, if the algorithm is dynamic, but if it's going, but that's plus. Now the plus one. Now I get the two keys. One key is what, the public one given to me. 25, but basically the public, just basically I get one key. It can be 25 or two keys, 25 plus 25, 50. if it's two public keys to one, if it's a private channel, really private channel, because I need one public key. We can get two public keys, 50. Now let's keep two public keys, 25 times 2, 50. So I can take my two public keys and log into a private channel, if it's LBC at any time because it's public. If I have the authority, the consensus algorithm also show. So basically, my goal here is to entangle my states with the field. So basically, the whole idea is if you're watching it, everyone's a slut and a slut in a buck. So I can be whether basically if I own something there in a quantum channel, quantum resource, I don't really have to give consent to open it. I don't have to say this. I don't have to say to you this is my thing. Send it now. I would say okay, yes, this active is mine. It stays there forever until someone don't you got a Polaroid. Basically, it's called polarization. So this conference, I see my stuff. I'm always eyeing my stuff. But if it's not, if I close my eyes, it disappears. If I ever show my public key, it disappears. Because no, I'm the only one opening my eyes to see that channel. Moving on from LBC, but it's polarity. Basically, polarity is just the concept of like I start with this combination, but I start with the combination XY, but XY implies order X to Y, but I don't give it order. So why not just Y to X? If I'm going down, up, but that means down up, but doesn't mean anything. So down, if it need down, if I'm going down the stairs, going down the channel, there's no actual channel to go down. But there's a channel. There's up and down in the wave spectrum, the wavelength, but that's not a thing that we can consider. So you got latitude of the wave. Okay, one thing. The wave, you got the wavelength and the wave amplitude. The amplitude, the frequency. How much it oscillates, So the wave amplitude, the wavelength is like the substrate of that structure. The wave amplitude is how that structure basically you got oscillation, which is the up and down of the string, and basically it's just frequency. The frequency is just the station you're tuning out. Basically the system is bidirectional. There's no cause and effect principle unless you involved, because it's instantaneous. So that's why it's entangled, because every wave remains coherent because there's from natural coherent decoherence, because they have a way that the information can propagate and distribute uniformly with no effect to its cause. For example, I can go to my YouTube channel, and then my YouTube channel, and then for me, I can observe my YouTube channel directly, from my YouTube channel, and then I'm trying to send a picture of someone to my mind, but that picture will not just go in my head, basically, if I want to tell someone to observe my YouTube channel, I can say, okay, go to my YouTube channel. I'm thinking now. I'm thinking it very poorly now. Let's get this video. Video. So basically, if I want to ever hack this channel, I have to. When I close my eyes, I stop seeing my channel. No one can go there, because go even that far, because there's no consensus there to read that document. It's a pointer problem, because let's call it a pointer problem, because it's a pointer. Basically, if you have a folder A and folder B, and A has a subfolder A1 and AB, A2, but those two, AB, A1 and AB, you get B1 and B2 are isomorphic. Then there's no need for hierarchy. There's basically, if A problem contains some files that solve those problems, and A2 contains some files that solve the same problem, solve like the recovery of the problem, A2, and then B2 does B2 does the same thing. This is a spectrum model because it's heterogeneous, because it's not linear. It's just categorical. So basically, if A1 is equal to A2, B1, promising B1, I take a file and I drag it to B1. Now B1 does the same thing to A, and this one, and then that file is then doesn't need to be operated on, because the file doesn't need to recover this automatically back into B, because how this works basically, in computers, basically, if I copy two files in two computers, I get a pointer to that file, That pointer is that it's just the shortcut, the shorthand file. But that shortcut file is just the minimal the compression of that one. But if I then take the compression in the hierarchy A1, A as root, and then I get B1, but B1 has uses root. B1 is children, but basically B1 is a root of its own. But you know B1 is a root of A1, and then you get A1 is A2, and then A2 folder and the same hierarchy as root 2. So you get root 1 and root 2. This can be the same as B1 A to A1, where B1 is root, and B2 A2 A2 is root. So basically, that's kind of heterogeneous problem mapping. So if you ever use A1 to B1 to A2, you kind of pointer mismatch. Basically, if I ever try to move B1 into on top of A1, and then you get a diamond. Basically, this is the same thing in model, but you get a diamond dependency issue, and that system is not conscious. So basically, something has to go because something has to be removed. So this one, something to do because if a system being homogeneous and working on linear principles, it works on signals, and the signals are can be go keep going based on the field evolving via to keep consensus principles. Because they just like give no consent to act. Just act or no. I need this now. Next one. 40 minutes. Next one. I don't believe I see A probability. So basically, PA is just probability of A. This is what I want to see. C and B, but basically I'm at B right now. But B does. I don't want to see anybody at A to see me. So why do I see? I just calculated my probability of someone being where I am on LBC and just remove them. And make sure there's no one there before I go there, because if there's someone there, that means someone's listening there already. So when I have the public keys, this one's just prove it, because you have two keys. I go there, then I shove one key, and then I keep one key. Basically, I observe my state. I observe only my state, my speech, and then keep the other key isolated. So this actually becomes something called epsilon. Now, epsilon means no state and no transition. Doesn't mean the key is not valid. It just means I'm not using it. So I keep the doors shut. So and I do my communication with my own private key. I already had with the channel. Back into where if I want to start, but you know what I'm saying. So that's cool. So obviously, the keys can be two public keys. Now the keys are public only. So you get the key can be in a rotation fashion. So I can send my public key first. One public key. I can get authenticated. And what? It's quantum zero trust principles, ZKP, or consensus principles. Basically, ZKP file compression for your government hierarchy systems. This is Sparse, the defense, attack, and offense system. So I can get send my public key first, and then log into the private channel. Let's call it so the private channel is O, which is my channel, and then you are what? A triangle, a square. What are you, Namdi? You are like a bubble. So you are your bubble. You come to my big bubble. I then say, okay, by law, shut off your public key. You have to show your public key. You basically give me one of your public keys. I give you back when you want to leave. But that's not what I want. I want you to have your public keys all the time. So I said, okay, take this public key. You can stay all the time on the friend. You can stay all the time forever. Just when you want to shut the channel off with an X. Press this button and then and then I'll shut off the communication. But that's like then he said yes, and then but you can come in and I can give you the consent to shut it off anytime. So you can come in first and shut it, but I can shut you off at any time, depending on how. It's the same thing in hierarchization. So X means shut off or the bubble or anyway two-way, but systems remain this two-way coherent based on a coding system. Basically, I can start. If I want to create my own wave theory channels, I want to be able to speak blue share. This is what I'm doing in quantum wave. One. Electric is hard. But okay. Let's see this. I want to piss now. Polarity is all about nothing. So basically, you want to polarize something. You want to be with a nothing. You want to be in a zone. I call it. You want to be in the zone for that buffer. It's like thermal shielding, or let's call it electromagnetic shielding. But if everything's a wave, then everything's thermatic. Anything can be pressured. The wave can be pressured to that radius. Basically, the wave can go bust if it's a classical system and it's picking up signals that it doesn't need. but it's like thermal shielding. So basically, thermal shielding is like a pattern of all of this. Anyway, I can shield my wave from this thermal waves because I made a channel, but the channel doesn't. It's not remain coming from once you shuffle it. Basically, so thermal shielding is just a concept that I shuffle the stuff coherently, show myself and move myself. There's consensus amongst everyone. So I get consensus, they get consensus, and everyone's happy. Basically, it's like the force equals mass demonstration. I need to piss, Namdi. Everything is something. I need to piss. 1 second, guys. Let me just pause. Okay, guys. I want to tell it. So basically, the consensus is bound to the system principles of tri-dag and partial system, tri-dag partial systems of substrate structures first, or substrate canonical systems, because the substrates are just a system. I've got some writing here. It shouldn't extend 1 hour because I was struggling to upload. So basically, I can model it in 2 ways, 3 ways actually, to give some consensus. But the 2 ways only if I want it to be secure consensus. So there's a 2 kind of 1 to 2 mapping. So the 1 to 2 mapping is for the private keys, and 2 to for the public keys for the aura cells. But this is operating the private keys because this you can shut now. So this, like you see this things here. Basically, I'll just read it out to you guys. So you can define an encoding, a nil encoding. The nil is nothing, no memory. I don't remember anything you said last time. We log it in. Nil memory equals nil state. Nil state. I don't remember anything. But this is for the nil state. Nil arm, epsilon arm, epsilon. To positive to negative. So basically, the negative to positive are just conjugates. You get the positive, the negative to positive, minus to plus. But it's only worth on radio waves, radio signals, and little radio hertz. And then you get the union, and the union on disjoint. So if I wanna start union, the disjoint. If I start from the disjoint union, I'm trying to connect to what I already connected to, what I remembered. But if I start from the disjoint, I never know you, and then I'm trying to connect with you for the first time. So I have to get this is the coherence model. So like you can see, the disjoints are like a union. It's just I'm connected to you. I've seen you before. Let's continue talking. And the disjoint first is like do I want to continue? So let me just connect to this unless you want to do spectrum radio wave. To ensure that the light is but I'm using finite model. This is useful to model some own finite model because there's no cause and effect that happens then. You have to try to plug in a function of time, because time is not really if you're not optimized for time, the time because time is auxiliary too. So I can say I want to maximize my time in this time basically if time is infinite, the radio wave is infinite. You can take an uncountable infinite set of time using a pi, because this is basically redshift. If you think it's kind of funny. I'm thinking of redshift because we're moving away from the center of the sun. We're getting in the span. We're moving away from the so-called center, but it's no center. So everything's just relative to me. So I'm trying to say that the universe is expanding from a relative point of view. It's no absolute center to the universe. Which can so this can be proven with this model basically. The redshift model basically, redshift I'm moving away, so I absorb more larger waves. So the smaller waves are the farther. So and when I'm looking down the spectrum, I'm looking at red. And I'm observing the electron, the things that happen far back. But far back things, if you look further, should appear more red. If the universe was imploding, red money is under redshift of gear button and thing. There's no order to it. Should be explained violet, but that one's wrong because if you get blue shift or cyan shift, I think it's red money is visible on the X-ray glasses, which is radio waves, and then you get radio rent money. Wait, what's it called? Roy G. Biv. Roy Biv. Violet is the last color of the rainbow, but that's not what I mean. Basically, if it's, I don't believe in that retro anymore because if we're moving the same or something, what we're moving from each other. But if we're all iterative, then we're all sparse, and universe can never evolve and adapt. So that one is somewhat true, but not fully true. Which I say to us like a dirty. I don't want to buy this guys. I'm a kid. Then we go here. Basically, you have like the force. Basically, you got the force encoding, plus force, the standard stuff. But you get a plus and a minus force, and you get if you get two positive force, you get a positive and a negative force. You get like if you get like plus force equals plus mass acceleration, you get like plus force equals negative mass acceleration. Because of conjugates, you know, you can take a positive force and get a negative, and you get a negative mass in the equation, and you get a negative force and get a positive mass. Net force equals 0. Something at rest stays at rest. But you know, because it's called net. Basically, everything stays just net is just the uniform for that radio wave net. So I could just call it net force for that switch. If you want to interact put force into it, so you can have something called thermal shielding. Let's call it shielding. Let's call it spectrum shielding, or like more radio shielding. That stops people literally using radio waves to pick out radio channels and decipher the message. Because you know you're all in radio spectrum, radio shielding. You don't really have to think about the radio waves for the quantum system. But I've tried to model this very badly. But this is the blue wave. So basically, there's kind of a color coding to it. Because you know, if I ever throw the color code, it says, you know, it's 15 minutes now. Okay, guys, I can't put it on YouTube. 15 minutes. Okay, guys, I have to end it now. Guys, I'll continue my next video. Thank you.